So, thank you very much. In this talk, I just present to you our experience in digitalizing system integration processes for small and medium enterprises, okay, by using a Jolie technology. So, the context is that of digitalization, that also the major of Dortmund talk about this. It's a very important issue now. Every company and every institution want to achieve this kind of digitalization in order to be competitive in a global market, okay? But the risk is that if we consider that we will have more software applications, the volume of the data we have to manage will increase. And then moreover, we have to deal with heterogeneous infrastructure because we would have cloud computing, we could have IoT devices, and our digital processes could be spread all over this part of the system. And the idea is that we risk to fragment all the digital processes among these parts, no? So the idea is that from our point of view, system integration could play a fundamental role for economic growth, okay? So, so far, clearly, the best practice for addressing system integration is a service-oriented architecture. I think that everybody agrees on this. The only problem with service-oriented architecture is that they are expensive. You need a lot of tools, you need a lot of skills, you need human resources, and they have a big impact also on your organization from the organizational point of view. So, if big player can easily adopt this kind of choice, this is not true for small and medium enterprises because they are too heavy for them. So usually, indeed, in the small medium enterprise, this is the usual architecture you can find. There is a big monolith that is represented by an ERP, for example, SAP, and then all the integration are made by hand on in some cases exchanging files, everything you want, and everything is connected to this big monolith on the middle, okay? But the problem is that if you are using this kind of architecture, you cannot escape from this because every single pieces you're adding in this architecture continue to feed this kind of architecture. And then, so there is a strong lock-in with the guys of this monolith. And then the company or the institution maybe are blocked in front of some initiatives, digitalization initiative, just because the partner cannot follow you, or maybe it is too expensive for this kind of initiative. So this kind of architecture could be a drawback for economic growth. So this is why we suggest to revolutionize the system architecture going towards a completely distributed architecture, and microservices could play a significant role in this perspective. The problem is that, as we discussed in these days, microservices introduced also a lot of complexity. So even if they are more flexible than the usual service architecture, the complexity they introduce maybe could make this kind of solution as expensive as the service-oriented architecture wants. So maybe from the point of view of costs, we could be in the same level. So this is our challenge. Our challenge is dealing with the system integration by using a fully microservice architecture approach by guaranteeing the following objectives: reducing time to market, reducing costs, and reducing the knowledge required for dealing with this kind of integration. Okay, so these three elements, time, money, and knowledge, I think we are talking about the same thing from different perspective. Because you can convert knowledge in money, or you can convert money in knowledge, and so on. It depends on from the point of view you are looking at this element. So in our approach, we are focusing on knowledge. So, and starting from the knowledge, we want to, as a result, to have results in terms of money or in terms of time. It depends on your approach. But the main point we are focusing on is knowledge. We want to reduce the required knowledge for dealing with this kind of problems. How do we do this? First of all, we select one single technology, that is the Jolie programming language, for dealing with the programming of microservices. Okay, Fabrizio yesterday told you a lot of stuff about Jolie, so I don't want to say anything more, but just I want to show you why I'm saying that it is reducing the required knowledge for developing a microservice, because in a Jolie script, you can find all the minimum required entities you need for defining a microservices. You have data entities, you have the interface, you have the communication endpoints, and you have the behavior of the microservices. This is just one simple script. Okay, it is an hello world microservices, but in these few lines, you have all the elements you need for dealing with microservices development. The other point we introduce is the an administrative tool platform called Jung, that is a commercial product developed by Italiana Software. It is fully developed in Jolie, and it provides some basic functionalities like deployment management, start and stop of microservices. You can consult the catalog of all the microservices deployed into the infrastructure, and then you can also automatic monitoring all the message exchange among all the microservices. Why I don't want to spend more time in Jung, because it is a commercial product, so I think it is not here the place where we have to discuss this. But I think that it could be interesting for you to discuss which is the main architecture of Jung. That there is a control panel node where it is equipped with a graphical user interface from which the administrative user can control all the services deployed inside the infrastructure. And then you have cloud nodes that are other microservices connected to the control panel that are in charge to register and deploy the microservices on the specific host. So usually you have the different hosts connected to the control panel, and in each host you have a cloud node connected to it. And each cloud node is responsible to govern the microservices deployed in that node. Since Jung is developed in Jolie and Jolie is developed in Java, we can have heterogeneous architecture where we have hosts with an operative system, Windows operative systems, and hosts with the Linux operative system, for example. And because in small and medium enterprises, it is very common to have an heterogeneous solution where we have some applications that are working on a Windows machine and other applications that are working on Linux. It depends. So it's very variable, the situation. We cannot say that there are a standard infrastructure we can deal with. And this is so the architecture of Jung. And this is the reference architecture, the ideal reference architecture for designing and developing microservices in our system. That means that we have a system integration space, we call in this way, because if you consider all the microservices deployed in the infrastructure, you can abstract away from the cloud node, and you can see all of them be part of a unique system integration space. And here you can program and develop your microservices connecting each other in order to create your system integration workflows. Okay? So this system integration space can be connected to external applications. Clearly, in this case, you need specific connector to them. For example, for SAP, we have developed a specific connector for SAP that allows us to see SAP as a Jolie microservice inside this system integration space. Or you could have other external application that, for example, can exhibit web services or JSON API, and then we can easily call them from a simple Jolie microservice from the inside. Then clearly, all the data sources we want to exploit must be reachable from the microservices that want to exploit them. And then some microservices could exhibit from some web user interface. So in our infrastructure, they should be reachable from outside. Maybe you can put a proxy on top of this in order to just select the call from outside. And so this is the main the main reference architecture. Here you can connect all the microservices in order to realize your system integration process. So the first thing I want to focus in is this. We introduce Jolie for reducing the required knowledge for developing single microservices. We introduce Jung for reducing the required knowledge for dealing with the global system perspective, the global knowledge. So thanks to these two approaches, we are able to reduce the required knowledge for dealing with this kind of stuffs. Which types of microservices can I develop inside Jung? I just decided to group these microservices in these categories. We can have pure computational microservices. That means that these microservices just execute an algorithm. They are transforming some parameter in in the request message, and then they give you a result, manipulating using some kind of algorithm this kind of data. Then we can have the pure data provider, that are microservices that just are a guard in front of a data source, for example, a database, or an electronic device, or an electronic board, or a file system, I don't know, or any kind of data source you want. And then we have pure orchestrator, that are microservices that are in charge to orchestrate and coordinate other microservices, so giving you some abstraction with respect to the basic ones. And then we could have microservices that are equipped with a graphical user interface in order to integrate human resources to interact with the system. Or finally, we could have a mixed composition of the previous 4 basic type of microservices. So we can have pure microservices that implements an orchestrator, but also it provides a graphical user interface for the final user. It depends on your situation and the situation you need to model. So this is the system integration engineering process we follow. It is very simple, nothing special in this. We have the analysis of the requirements, and then we identify the data entities involved into the system integration process. Then we identify the microservices involved in this process. Finally, we design concretely the process architecture in order to implement, to fulfill the initial requirements, and then we have implementation and deployment as the final stages. The important fact is that data entities are directly defined by using Jolie types. When we identify microservices, we directly define the interfaces of the microservices by exploiting the language, the interface language of Jolie. And here, when we are designing the process architecture, so far we are using sequence chart diagrams for expressing the relationship among every microservices, but we are working on introducing choreographies languages in order to automatize also these steps, okay? And then the implementation is completely done by using a Jolie language, okay? Finally, deployment is performed on the Jung platform. One interesting thing is that clearly this is a top-down process, but we are able to enable also the bottom-up approach. Why? Since we are reducing significantly the required knowledge for dealing with the microservices, we are able to go back on the previous stages, refactoring the previous decisions. So in this case, we are able to speed up also the first analysis phases, because we are able to immediately go deep, go to put our hands in the development of microservices, because we are able to go back on the previous stages. Another important fact is that in this engineering processes, the first 4 stages deal with the global knowledge of all the system, whereas the last 2 deal specifically to the implementation of this on each single microservices. Usually in a big infrastructure with big teams, the first 4 stages are in charge to architects, whereas the last 2 stages are in charge of the development. Here, we are saying that the team should acquire also the architectural competencies for dealing with all the system. Okay, this is quite different from the mainstream we are usually listening about microservices. And so for us, a team must think globally and act locally. So we have to put inside the team also the knowledge of all the entire system. Because if we want to reverse our engineering process because we want to revise some decision we taken before, maybe here we decide to not implement a new microservices because when we are doing this, we understand that it's too complicated. We want to exploit to expand an existing microservices. We have to go back and to refactor an existing one. But in order to do this, we have to have a global perspective of what the system is, because we have to pay attention on the dependencies of other flow have on these previous microservices. So here I can just report one real scenario where a customer, in a customer where we exploit this approach, and we asked them to give us a sort of metric for measuring the benefits they had by exploiting this approach. And the only metric we found was comparing the actual day, the actual time they use for developing solution with the estimation of a competitor for doing the same thing. In this case, we have a great number that is a reduction of time of 75%. Okay, it is just one case. We cannot generalize this. But I think it is quite significant for starting to understand that maybe this approach could work in a large scale for those small medium enterprises where there are no so big infrastructure inside. Then as a small team of just 3 people can manage more or less all the microservices they have. At the present, they have quite 50 microservices that manage more than 10 different workflows and system integration flows inside the company. So we are quite satisfied by this result, even if we know they cannot be generalized. And so, what is the meaning of this talk? The meaning is that I think that system integration can play a significant role for the economic growth of small and medium enterprise, and distributed system could help them to be more flexible and to implement easily some digital initiatives. But in order to do this, we need to drastically reduce the required knowledge for running this kind of solution. So in our approach, we are trying to do this, reducing the necessary knowledge for doing this kind of stuff. And we do this by introducing 2 technology in the field, that is one programming language, a unique technology for doing all the microservices. This is an anti-pattern, maybe, because usually microservices was born to be agnostic from the technology, but in this case, it helps us to have a common language for doing everything the same stuff. And a platform that is just an administrative tool for managing all these kind of microservices. We validate this approach on a customer, and we have some encouraging results. And so, what do you think about this? Thank you very much for your attention.
Yeah, thank you. So, do we have any questions? Well, yeah, okay.
So, thank you for the cool talk. I was wondering, you mentioned that there is a lot of people who run Microsoft Windows hardware things, and you would like to help those guys too. So now still I sit on my desk, and there is this Windows server somewhere else, and can I fire up jobs on that other machine with your approach, or?
You can deploy if you have installed the cloud node, you can deploy directly microservices there, and then you can start and stop that microservices that are run as services inside the Windows server. So
there needs to be some Jolie instance running there already.
yes, of course, you need you need to install Jolie there, of course. And Jolie requires Java, so you need a Java virtual machine as a minimum requirement for doing this.
So, further questions? I have a question.
Yeah.
How many memory does this consume?
Sorry?
How many memory on your cloud node do you need to run so multiple Java virtual machine and Julie and Jung?
The the problem is maybe no, it's not a problem. It depends on the microservices you have, in the sense that depending on which kind of functionality it provides, you have to pay more attention to memory. But usually, for example, in Linux system, you have a good optimization of the management of a Java virtual machine, and so they are not so heavy. In that specific customer, we have we have more or less 50 microservices within the same machine, and you have I think they have 16 gigabyte of memory in RAM, just as a minimum requirement, and the system is working good without any problem. So you don't need so extremely advanced architecture for doing this. So I think that could be a good solution for those enterprise that they don't need so extremely advanced architecture, and it's very easy. Sorry.
Just to answer that, since I have experience on running Jolie on some edge device, I made it run on a Raspberry with Alpine JDK installed, so it runs even the lowest configuration possible of a JDK, and it performs really well, especially the
Jolie for itself, it doesn't require a lot of memory, very less memory. The problem is the Java virtual machine, that you have to pay that price. Okay.
Okay, thank you. Another question? Okay, then thank you again